Okay, so this time we're going to do some probability from contingency tables. All right, so we're going to select an individual at random from a population of students who are classified by gender and by their favorite subject. So you'll notice that event A is that we select a student who is female, and event B is that we select a student who chooses math as their favorite subject. Now you'll notice that I have gone and made all the female going across yellow, and all those who like math as their favorite subject blue going down, and where they overlap, that's red right here. All right, now, so let's find each of these probabilities. The probability of A, the probability that they're females. Well, let's notice that this line of females has a total here. There are 1,600 females total. So this probability, the probability of A, I'm going to use my draw feature again, is 1,600 women out of the 3,000 total in the sample. So 1,600 over 3,000. And it may be easier when we have big numbers like this just to change it into a decimal by saying 1,600 divided by 3,000 in your calculator. And that's 0.533333. I'm going to round it off to about 4 decimal places. 0.533. All right, now let's get the probability of B, which is the probability that someone chooses math as their favorite subject. If we look down here, there's a total for all of those people who like math. It's 1887. And I'm going to do it down here just so I don't crowd myself. So it's 1887 out of the total number of students, 3,000. And again, we can let our calculator do that as a decimal, 1887 divided by 3,000, and we get 0.629. And it doesn't have any decimals beyond 0.629, so that's it. All right, now 3, we want the opposite of A. Now, we could count up everything that is not yellow, but what's easier is to use the complement rule, which is to take 1 minus the probability of A. And we got 0.5333 is the probability of A. So 1 minus 0.5333 is going to give us 0.4667. All right, now 4, the probability of A and B. Remember that and means we want both to be occurring at the same time. We want where yellow and blue come together, and that's right here. 1,192 students out of the 3,000 possible. So if I put that into the calculator, 1192 divided by 3,000 gives us 0.3973. Okay, so now let's look at number 5, the probability of A or B. Now we could add up all of the blue and all of the yellow and then put it all together. We could do that. But let's instead use the formula for OR that is in your slides. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Now, since we have all 3 of those, all we need to do here is fill in. So the probability of A was 0.533, and the probability of B was 0.629, minus the probability of both, which was number 4, 0.3973, and And now let's put that into the calculator, and we'll have the probability of A or B. And that is 0.765. And realize your probability should never be greater than 1, so if you get something greater than 1, you've done something wrong. Now let's go to 6. On number 6, we need to use our conditional probability formula. The probability of A given B is equal to the probability of A and B over the probability of the second one in the notation, the probability of B. Well, we know the probabilities of both the bottom and the top of this. So let's see, A and B was 0.3973. And then the probability of B was, that was number 2, 0.629. And then let's just let our calculator do the work. 0.3973 divided by 0.629 gives us 0.6316. And there we have it.